Okay, this is our Physics 112, lecture number 3. I'm going to give you another example of vector addition by using the method of vector decomposition. So first, let me draw a coordinate system. I have x-axis, then I have y-axis, right? Sometimes my lines might not be straight. You have to excuse me. Now, this is my first vector. Let's call it vector A. And it's about, it's, let's say, 30 degrees, making with a negative x-axis. Then I have another vector B, in that direction, and let's now put the magnitudes. Vector A, magnitude of vector A sorry, is 10, and magnitude of vector B is, let's say, 12. Okay, now I am not mentioning any units because I am not saying what A and B are. They can be force, they can be displacement, they can be velocity, they can be momentum, acceleration. As long as A and B have the same units, it's fine right now. Okay, so now you see vector A is not on x nor y axis, so I do not have to I have to decompose vector A. But vector B is already on positive on the x-axis. It's pointing in the positive x direction, so I do not have to decompose this vector. So remember, when a vector is already on the x-axis or y-axis, you do not have to decompose them anymore. But if they are not on x nor y-axis, then you have to decompose them. So vector A, first of all, let me write vector A x magnitude, which I'll write as magnitude of AX will be A, magnitude of A cosine 30 degrees. Okay, why is that? Because this component, let me draw the component for you. This component is AX. This is the adjacent side, and this is vector magnitude of vector A. So in this triangle, that is A cosine 30. So this is A cosine 30 degrees. Similarly, for this y component, or I can call it AY, then this will be A cosine, A sine 30 degrees. Alright, so I write them as vector AX and AY because I want to use these little arrows so that you can see that vector A is decomposed into vector AX and vector AY. So AY and AX together will give you vector A, right? But you cannot consider all three of them at the same time. Once you decompose them, A is no longer there. You have now AX and AY. So magnitude of AX is A cosine 30 degrees. But magnitude of A is, I said, 10. So 10 times cosine 30 is 0.866, which will be 8.66. That is AX. And similarly, I can find AY. Magnitude of AY is A sine 30. And we know that sine 30 is 0.5. 10 times 0.5, that will give you 5. Now, B is only in the x direction, and I can say that magnitude of B is the same as B magnitude of BX, which will be just, I said 12, right? So at this stage, what you have is you have three vectors. One is AX pointing in that direction, that is AX. One is B or BX, vector B, and it has only one component, BX, because it has no Y component. And then I have AY. I have three vectors, right? So now obviously AX and BX are on the x-axis pointing in two opposite directions. On the y-axis there's only one vector, AY. So it's clear our resultant vector will have Y component will be in the direction of AY, and for X component, the RX component will depend on whether this guy is bigger or this guy is bigger, right? And we see that this is 8.66, that is AX, that is 8.66, this guy is 12, right? I gave you it's 12. So this guy will be bigger. So obviously the number that you will have, the vector that you will have will be pointing in that direction for X component. So let me draw the final picture. So my Rx component will be in that direction. So that'll be my vector Rx, and then Ry will be in that direction, right? And the magnitude of Rx is it is 12, that coming from B, and then minus 8.66, that is from AX pointing in the other direction. So that will give me 12, so that's 3.34. Alright, you can check that. And then for Ry, it will be the same as AY, and which is equal to 5. Okay, so now I know what Rx and Ry are, the magnitudes are, and the direction will be like this, right? All I have to do is use the Pythagorean theorem and I can find this angle theta. So first of all, let me find the Rx, the magnitude of Rx. Magnitude of R is equal to square root of Rx squared plus Ry squared, and Rx squared is 3.34 the whole squared plus Ry squared is 5 squared, right? So now before you hit your calculator, let me tell you something. Sometimes you make mistakes by using the calculator and you get wrong number, but you do not check. You can make a little mental check here. See, this is approximately 3.34, so it's approximately 3, so 3 squared is about 9. And it'll be a little bit bigger than 9 because of that 0.34. And then here you have 5 squared is 25. So 25 and 9 will be, if you add them up, it will be 34. So with this little 0.34, it will be a little bit more than 9, so that when you add up, it will be approximately 35, 36. So then the square root will be about 6, right? So as long as you get a number close to 6, then you will be correct. So let's check if we are correct. So let's turn that on. And then this is 3.34. So I have to take, this is a new calculator that I've never used. So 3.34, then I square it, plus 5 squared, and I think I have to close bracket, and it's equal to, see, 6.0129. So approximately 6.01. So that number must be correct, right? At least in the ballpark. Now, what about this angle theta? Then angle theta, as you can see that this component is Rx, this component is Ry. So Ry divided by Rx is tangent theta, right? You can check from that triangle. Tangent theta is equal to Ry divided by Rx. So theta is tangent inverse ry by rx. So theta is equal to tangent inverse ry is 5 and rx is 3.34. Right? So let me see how I find tangent inverse on this thing. So there must be tangent inverse. I can see very well here. So that will be shift and tangent inverse 5 divided by 3.34. That will give me 56.257 degrees. So it's about 56.257. So let's say 26 degrees. That'll be correct. Alright, so that's how you do vector decomposition by using for adding vectors. Alright, okay.